Good evening, everyone. Tonight we're going to go through and talk about light waves. And especially we're going to look at the comparison between light waves and mechanical waves. So first thing we want to do is talk about what a light wave is. Just to recap, a wave in and of itself is a form that transfers energy from one point to another. However, it is not responsible for transporting matter. So that is really important to remember that we transport energy but not matter. Light waves are really unique in the fact that they are made up of electric and magnetic forces. To my side, we have a picture here, and in that picture or diagram, it illustrates what a light wave might look like. So what you might notice right off the bat is it's actually made up of two separate items. It's made up of an electrical force and a magnetic force. Thus, we often refer to light waves as electromagnetic waves. An electromagnetic wave or a light wave still consists of a lot of the original or typical wave properties. It has a wavelength, it has amplitude, it has an origin, it has a crest, a trough, and so forth. We still measure frequency. In fact, when we look at the electromagnetic spectrum, which we'll be doing in the next video, we really look at frequency to be able to determine where we're looking at in regards to an electromagnetic wave and how much radiation signature it has. What we're going to do really quick now is take a look at the differences and similarities between mechanical waves and light waves. So prior to talking about light waves, we covered mechanical waves in class. And mechanical waves are most commonly sound waves, are the primary example that you can look at. But we're going to take a look at how the properties within a mechanical wave compare to that of electromagnetic. So first, let's talk about their similarities. So one of the biggest similarities between the two is they both are responsible for transporting energy from one point to another. Again, they do not transport matter. So they're not taking that molecule at the beginning and transporting it all the way to the other end. They're taking that energy that starts off from the disturbance at point A and transporting it to point Z. How that is accomplished is the collision of those molecules, and when those molecules collide or vibrate in place, causing that collision, we have transfer of energy. That energy is propagated in the opposite direction of its energy source. Another similarity that both of them have is that they both can only travel as far as their level of energy will take them. That means it's kind of similar to a car with gas. So if you put 10 gallons of gas in the car is not going to be able to go further than that. Same idea with a light wave or a mechanical wave. If they have so many joules of energy, they're only going to be able to move the distance in which those joules of energy can cover. We see as they progress usually a reduction in their amplitude because that energy is being expended as it moves. Some differences, we're going to take a look at the differences between mechanical waves and electromagnetic waves, aka light waves. One of the biggest differences, big differences between the two is that a mechanical wave requires a medium to move. That means it has to have something to help carry the wave. An example of a medium could be water, it could be air, it could be still. Really important about electromagnetic wave, it doesn't require one at all. So that means it can travel through outer space. And this is extremely important because the sun is one of the largest producers of electromagnetic waves. And without the ability for it to travel through outer space in a vacuum, we as humans would not be able to survive and the Earth would not exist in the same way that it does. Another big difference between mechanical waves and electromagnetic waves is that mechanical waves can be composed of both longitudinal and transverse waves, whereas electromagnetic or light waves can only be composed of transverse waves. Longitudinal waves do not exist within the electromagnetic spectrum or within light waves. Examples of mechanical waves could be seismic waves, it could be sound waves, it could be a ripple within the water. An example within the electromagnetic wave spectrum could be radio waves, infrared waves, visible light, as well as gamma rays. Within the electromagnetic spectrum, also really important is the fact that there are high levels of radiation that can exist, the higher frequency and the higher energy that they carry, which can be very dangerous not only to humans, but also other organisms on Earth. That's about it. If you have any questions, try to rewatch, and if so, shoot me an email. But that wraps up our comparison between light waves and mechanical waves. Thanks for checking in.